Welcome to another episode of Terry's Notes, and today we are going to be looking at the multiplication of matrices. So let's talk about the first kind of multiplication, which is what we call a scalar multiplication. Right? Which is very straightforward. So if we had a matrix A, and the matrix is 1, 2, 3, 4, and I told you to find the matrix 2A, right? To get the matrix 2A, all we need to do is take the matrix A and multiply by 2. Alright? What we have to do now to get the answer, we take the matrix on the outside, the number on the outside, and we're going to multiply by each of the elements. So 2 by 1 will give me 2. 2 multiplied by 2 will give me 4. 2 multiplied by 3 will give me 6. And 2 multiplied by 4 will give me 8. Right? So the matrix 2A is really 2, 4, 6, 8. Let's do another one. Let's say I have B is equal to 1 minus 1, 2, 4. Right? And I want to get the matrix 3B. Right? So 3B will simply be 3 multiplied by the matrix B, which is 1 minus 1, 2, 4. Again, we're going to take the constant on the outside and multiply it by each of the elements. So 3 by 1 will give me 3. 3 multiplied by minus 1 will give me minus 3. 3 multiplied by 2 will give me 6. And 3 multiplied by 4 will give me 12. Right? So as you can see, scalar multiplication is pretty straightforward. So let me just do one more example concerning that. So let's say I have A is given by 1, 0, 2, 1, and B is equal to let's say 2 minus 1 minus 2, 1, right? And I ask you to find A plus 2B, right? So the first thing we're going to do, we're going to write down what A is. A is 1, 0, 2, 1 plus 2B. So I need to put plus 2, what the matrix B is, which is 2 minus 1 minus 2, 1. Right? So I can't do anything with A as yet. So 1, 0, 2, 1. I'm going to leave it as is. Plus, we're going to multiply 2 by B. So again, we have to say 2 by 2, which will give me 4. Then 2 by minus 1 will give me minus 2. 2 by minus 2 will give me minus 4. And then 2 by 1 will give me 2. And we are just adding two matrices here. So we're going to add 1 plus 4, which will give me 5. Then 0 plus minus 2 will give me minus 2. Then 2 plus minus 4 will give me minus 2. And then 1 plus 2 will give me 3. Okay, hopefully I didn't make a mistake there. Right, so the matrix A plus 2B is given by this guy here. Okay, let's do the more difficult one. Okay, so let's do the more difficult multiplication, right? So let's say we have two matrices. We have A is equal to 1, 2, 1, 4, right? And we have B is equal to 2, 1, 2, let's say 3. And we want to find the matrix A, B. Now this is not a scalar multiplication. It's saying that we need to take matrix A and multiply by the matrix B, which is 1, 2, 1, 4, multiplied by 2, 1, 2, 3. Now, something that I want you to stick in your head, just remember when you're doing this type of multiplication, always remember it's row by column. You will understand what I mean in a little bit. So matrix A is of the order, it's a 2 by 2 matrix because you have 2 rows and 2 columns. Matrix B is also a 2 by 2 matrix, right? Now, what we have to do, now this is what you need to remember, row by column. So we're going to take our first row, which is this, in the first matrix, and multiply it by the first column in the second matrix, right? So what I'm going to work it out on the side for you, so you will see exactly what I'm doing. So I'm taking 1, and I'm going to multiply by 2, so it's 1 by 2, and I'm going to add it to this 2 here, multiplied by this 2, so it's 2 by 2, which will be 2 plus 4, which will give me 6. So my first element will be 6, right? Now to get this term here, this term, we have to take our first row, which we already have, that's this, and multiply by our second column, right? Which will be 1 multiplied by 1, 1 by 1, plus 2 by 3, 2 by 3, and that gives me 1 plus 6, which is 7. So this term here is 7, right? So look at what I did. I took the first row in the first matrix and multiplied by the first column. That's how we got the 6. Then I took the first row in the first matrix and multiplied by the second column in the second matrix, which is the 1, 3, and I got 7. Right, now we're going to use the second row now in the first matrix, the 1, 4. So I'm going to take 1, this 1 here, and multiply by this 2. So it's 1 by 2 plus 1 by 2 plus 4 by 2, which gives me 2 plus 4 2 is 8, which gives me 10. So this is 10 here. And then to get the last term, we take the 1, 4 and multiply by the 1, 3. So we get 1 by 1 plus 4 by 3. And that gives me 1 by 1 is 1, and 4 by 3 is 12. So this gives me 13. So this is 13, right? So the product AB is 6, 7, 10, 13, right? And you see this here? This is what I've done here. You need to know exactly what I'm doing. These are the steps. That's how I got the 6, the 7, the 10, and the 13. Right? So keep in mind it's row by column. Right? Let me do another example. Suppose we have the matrix P, and the matrix P is given by -1, 2, 2, 1, and Q is equal to let's say 1, 1, 2, 3, and I want to find PQ. So PQ will be -1, 2, 2, 1, multiplied by Q, which is 1, 1, 2, 3. Right. So again, remember row by column. That's what I told you to remember. So we're going to take the first row in the first matrix and multiply by the first column in the second matrix. So it's -1 multiplied by 1 plus 2 by 2, which is -1 plus 4, which is 3. So first term is 3. Then I'm going to keep with the first row and multiply by the second column in the second matrix, which is the 1, 3. So that will be -1 multiplied by 1 plus 2 multiplied by 3, right? And that'll give me minus 1 plus 6, which is 5. So this is 5. Then we're going to deal with the second row in the first matrix. So I'm going to take the 2 by 1 and multiply by this one here. So it's 2 by 1 plus 1 by 2. So we end up with 2 plus 2, which is 4. So this comes here. Then I'm going to take the same row and multiply by the 1, 3 now. So it'll be 2 by 1 plus 1 by 3, which will give me 2 plus 3, which is 5. Right? And this is how we get PQ. Now, I want to do one more thing. Now, if you look at this question, you realize, well, it's just addition and subtraction, right? You just need to remember the steps involved, and it's a very easy question. Now, we just worked out PQ. I want to show you something. Suppose, so let me just write back what was P? P was minus 1, 2, 2, 1. Minus 1, 2, 2, 1. And Q was 1, 1, 2, 3. 1, 1, 1, 1, 2, 3. Now we just worked out the product PQ, and we got 3, 5, 4, 5. 3, 5, 4, 5. We got 3, 5, 4, 5. Right? Suppose I come and I ask you to find QP instead. Does the order matter? You think I'm going to get the same answer as 3, 5, 4, 5? Well, let's find out. So we're going to work out QP. So I'm going to write Q first. Right? 1, 1, 2, 3. And P is minus 1, 2, 2, 1. Right? So we start. We're going to take the first row in the first matrix and multiply by the first column in the second matrix. So this will be 1 by minus 1 plus 1 by 2, which will be equal to minus 1 plus 2, which is equal to 1. So the first term will be 1. Then we're going to take the 1, 1 and multiply by 2, 1. So it's 1 by 2 plus 1 by 1. Right? Which is equal to 2 plus 1, which is 3. And then I'm going to deal with the second row. So I'm going to take, so this is 3. So it'll be 2 by minus 1 plus 3 by 2, and this gives me minus 2 plus 6, which is 4. And then I'm going to do the last one, which is 2, 3 by 2, 1. So it's 2 by 2 plus 3 by 1, right? Which is 4 plus 3, which is 7, right? So if you notice what QP is, QP is 1, 3, 4, 7, and PQ is 3, 5, 4, 5. So therefore we can say that PQ is not equal to QP. This is another typical examination question. They are going to ask you to check to see if we multiply the matrix in one direction, if we are going to get the same thing in the other direction, right? And the thing is, you will not. All right, and it's very easy to prove it, right, by showing your calculations. So as you can see, addition, subtraction, multiplication of matrices are pretty straightforward. You just have to remember the method, right? Because it's simple addition and subtraction and multiplication. All right, so I want you to practice these questions, and matrices are going to be very easy, because once you know how to multiply a matrix, you're going to use the matrix to solve simultaneous equations, and I will do this in another video. Okay, take care.